This video is for parallel lines and angles. Remember, taking the notes for each of these videos will give you a Bellwork score of 20 when I return on Monday. So make sure you go through and copy the notes as you see them here. First off, a little bit of a review of what you talked about yesterday. On the first diagram here, what type of angle pairs are in this picture? Well, of course, we have anytime two lines intersect, we have vertical angles, and in this case, angle 1 and angle 3 would be vertical, and also angle 2 and angle 4 are vertical. The other type that we always have anytime two lines intersect is we can always identify some linear pairs. And there happen to be four linear pairs in this particular situation, angle 1 and angle 2. Angle 2 and angle 3 are a linear pair. Angle 3 and angle 4, angle 4 and angle 1. Remember, to be a linear pair, they have to share a side, like this blue one. And their other two sides have to make a straight line. So angle 1 and angle 2 share the blue side, and their other two sides make that straight line. What relationship do the angles in the pair have? Well, vertical angles will always be congruent. So anytime we have vertical angles, we can make a statement that they're congruent. We can set them equal to each other. If we have a linear pair, are always supplementary. Remember, supplementary means they add to equal 180 degrees. And yesterday in class we learned that when we have two lines that are intersected by another line, in this case line T, that line, remember, is called a transversal. We have several different types of angles formed. One type of angle is corresponding. Angles in the same position, like angle 1 and angle 5, are corresponding because they're in the same position. Another type of angle is alternate interior. Alternate interior would be like angle 4 and angle 6. They're on opposite sides of the transversal and in the interior between the two lines. Another type is alternate exterior. In this case, our alternate exterior could be like angle 2 and angle 8. Again, they are on opposite sides of the transversal, thus the word alternate. And they are outside in the exterior of the two lines. And the final type is same side interior. And same side interior, like the name says, they have to be on the same side, so angle 3 and angle 6 are the same side interior. The other pair happens to be 4 and 5. Now, as to the question, what relationship do these angles have? Well, unlike vertical angles that will always be congruent, and linear pair that will always be supplementary, these have none at this moment. But today I'm going to share with you some relationships that they will have provided a given condition happens to be true. So let's dive right into that. So we'll need to look at these four pairs of angles and see what characteristics occur. All right, well, first off, the corresponding angles postulate. If two or more parallel lines are cut by a transversal. So we need to have parallel lines and we need to have a transversal. Now for us, these blue marks here, these two blue arrows on my screen, on yours I believe they're just black, they signify that we have parallel lines. So it's a way of showing the two lines are parallel. Then this line here would be the transversal. So if we have two parallel lines and a transversal, if we have those two conditions, then what we know is that the corresponding angles have to be congruent. So since we have both of those conditions in this picture, we know the corresponding angles are congruent. The following statements have to be true. Angle 1 has to be congruent to angle 5. They're corresponding because they're both in the top left of the intersection at which they occur. Angle 4 is congruent to angle 8. They're both in the bottom left. Another pair of corresponding in the picture is angle 2 and angle 6. They're both in the top right. And the final pair is angle 3. It's going to be congruent to angle 7. They're both in the bottom right. So anytime we have first two parallel lines, two or more, and we have a transversal that cuts through them, then we can make a statement that says that the corresponding angles have to be congruent. We know that for a fact. Moving on to alternate interior angles, it has the same two conditions. We must have two parallel lines. We see the parallel marks, so that's check. And we must have a transversal. Here's our transversal, check. Then what can we say is true? The alternate interior angles have to be congruent. So if the lines are parallel, not only are the corresponding angles congruent, but the alternate interior angles are congruent as well. So in this case, one pair of alternate interior would be 4 and 6. They are in the interior between the two lines, and they're on alternate or opposite sides of the transversal. The other pair of alternate interior would be 3 and 5. So angle 3 is congruent to angle 5. We only have two alternate interior angles in this particular situation when we have two lines and one transversal. Corresponding angles, as you saw, we had 4 different pairs. So again, if we meet the two criteria, then we can make a conclusion. We can state that the alternate interior angles are congruent. The next statement, alternate exterior angles theorem. That means that this statement can be proven to be true. Again, has two conditions. First condition, we have to have two parallel lines. And second condition, we have to have a transversal. If those two conditions are true, then we can say that the alternate exterior angles are congruent to each other. And you'll recall that alternate exterior are just the opposite of alternate interior. They have to be in the exterior, outside the two lines, and they have to be on alternate or opposite sides of the transversal. So angle 1 is outside. Now down here, 8 and 7 are both outside, but 7 is the one on the opposite side. So it would be the alternate exterior with angle 1. So angle 1 and angle 7 are going to be congruent. Again, but only if the lines are parallel. If the lines are not parallel, they will not be congruent. They'll still be alternate exterior, but not necessarily congruent. The other pair would be angle 2 and angle 8 are going to be congruent, which means they have the same size. Finally, same side interior. You're looking very familiar. They have to have two parallel lines. They have to be cut by a transversal. If those two conditions are true, then wait, here, the same side interior are going to be supplementary. They're not going to be congruent. They're going to be supplementary. So angle 3 and angle 6 are both in the interior, and they're both on the same side. So the measure of angle 3 plus the measure of angle 6 has to equal 180 degrees, since they are supplementary. And likewise, 4 and 5 are both on the left side of the transversal, and they're in the interior. So the measure of angle 4 plus the measure of angle 5 has to be 180. So we knew that angle 4 was, say, 70 degrees. That leads us to the measure of angle 5 would have to be 110, because 70 plus 110 is 180. And if we knew the measure of angle 4 was equal to 60 degrees, that leads us to the measure of angle 5 being 120 degrees. Let's finish off. Identify the pairs. Hit pause and write down all the different pairs that we have. Then when you have them, press play again. Welcome back. The alternate interior angles are angle 2 and angle 7, angle 6, and angle 3, because they're on the interior. The corresponding are angle 1 and angle 3, angle 2 and angle 4, angle 5 and angle 7, angle 6 and angle 8. Remember, with corresponding, there turns out to be a total of 4 different pairs. Alternate exterior, angle 1 and angle 8 are on opposite sides and outside the two parallel lines, and so are angle 5 and angle 4. Same side interior, hopefully you got angle 2 and angle 3, angle 6, and angle 7. Now let's take a look at two examples that will allow us to apply our properties. So in this case, we have this diagram. Remember, the arrows indicate parallel, and this is a transversal. So since we have parallel and a transversal, there's something special about our angle types. So in this case, these two angles are both on opposite sides of the transversal and outside of the lines. So these are alternate exterior. And remember, alternate exterior turned out to be congruent. The only one that wasn't congruent was same side interior. So alternate exterior congruent means that 8x plus 15 has to equal 2x plus 51. Create some zeros. 6x plus 15. Here's one zero, so we have 51. Create another zero. So 6x, here's the zero, equals, I think that's 36. And divide by 6 makes x equal 6. So when x is 6, both of these are the same. So if I put 6 in, 8 times 6 plus 15. 8 times 6 is 48. And 48 plus 15 is 63, I think. And 2 times 6 plus 51 would be 12 plus 51, also 63. So x equals 6 does check out. In our final one, again, we can see the symbol for parallel. And we have the transversal. So these two lines, if we can identify the type, we know the relationship. Well, they're both on the right side of the transversal. They're both on the same side. So these are same side interior. And if you look back into your notes, when the lines are parallel and we have a transversal, the same side interior are supplementary. So 2x plus 12 added to 3x minus 17 equals 180. Combine like terms, we have 5x, and 12 minus 17 is negative 5 equals 180. 5x equals 185. X equals 37, I believe. Make sure you check with a calculator. So we found the value of x. Now we have to find the measure of each angle. So 2 times 37 plus 12 would be 74 plus 12. That would be 86. And 3 times 37 minus 17 equals 111 minus 17, which would be 94. And those two do add up to make 180. So the 37 checks out for us. Now before you go back to the screen that said same side interior in your notes and put a star on both ends of that statement, and you'll receive some extra credit when I see that. Good luck on today's worksheet. Don't share that little tidbit with anybody else. Have a great day. I'll talk to you tomorrow.